Communication with an embedded application is not necessarily easy, especially when it's going to be working in an ad hoc environment. DDS, or the dynamic or the data distribution system, is one approach that makes designing systems, especially with a lot of different cores, a lot easier. David, could you tell us a little bit about what DDS is?
Sure. So DDS is a standard that provides a framework for building highly reliable distributed real-time systems. So it's a way for different applications or components of applications or subsystems within these systems to communicate. So for example, from your sensors to your perception or localization algorithms to your autonomy functions, route planning, down to actuation of the system that you're operating in. So all of these have different applications that manage and control them. And what DDS does is provides a way for all of these components to communicate with each other reliably in real time.
Okay. Now, where are some of the places where this is actually used? For example, it could be used in self-driving cars to essentially manage the communication with the entire network.
So that's correct. So vehicles of all sorts, so planes, trains, automobiles, anytime you have a distributed real-time control system, is a good fit for DDS. So certainly used in automotive applications. Also, other types of vehicles like used for agriculture, construction, and mining. It's used in medical equipment and hospitals. So things like for patient monitoring, medical imaging, for example, and used in defense applications or aerospace and defense applications like, aircraft, coordinate all the systems on board a ship, for example, and in things like missile defense systems are some of the common applications.
One of the things that this uses, that's a publish subscribe type environment that can be used well in ad hoc designs where you're going to be adding things, changing things dynamically. Can you talk a little bit about why that's important?
Sure. So that's important because these systems tend to evolve over time. So you want to add new capabilities. So I think we're all familiar with, for example, cars getting more autonomous over time. So one nice thing about publish subscribe is, if I'm publishing sensor data or location data, all I need to know is about the type of data I publish. I don't need to know what other applications might be using that data. So as the system evolves and I want to add new capabilities, those are just new subscribers in the system. And if that new subscriber needs location data, it subscribes to location data. It doesn't care where that location data is coming from. I want to improve my localization algorithm and publish better location data. I don't have to change any subscriber of that location data. So it makes it very easy to evolve and integrate these systems over time as they become more complex and you change and add functionality within the system.
Okay. Now, RTI has their own DDS system, and one of the new things that you have is talking about observability of the system. Can you tell us a little bit about your product, and also what is this new framework?
Sure. So Connext DDS is the name of our DDS solution. It's the most widely used DDS product. It's been in the market about 20 years. The new capability that we're introducing now for full stack observability is recognizing some fundamental changes occurring in the landscape of these, distributed real-time systems, which is, in particular, as more autonomy capabilities get integrated into these systems and they become more geographically distributed or deployed in environments that might be less controlled, there's a lot less predictability about how the system is going to behave at runtime of the system. So if you think about a system just deployed within a vehicle, whether it's a plane, a train, a car as the vehicle, what the network within that vehicle is. But now if you have different vehicles that might be communicating or collaborating with each other, so for example, for coordination purposes at a mining site, or for swarming applications, or that might be, teleoperated remotely, you now no longer know exactly what the deployment topology of the system is. It's going to change very dynamically as vehicles, may be added or removed from the system or come into range, or you may get new operators. The networks themselves might change. If they're close, they might be communicating, with wireless or Wi-Fi. If they become, more widely distributed, they might be communicating over a cellular network, or maybe even a satellite network in certain cases where cellular might not be available. So now that these environments are much more dynamic in terms of what the participants are and what the underlying network capabilities and capacity is, there's a lot more things that might sort of go wrong at runtime that you can't really predict at the time that you develop the system, because every deployment is going to be unique and dynamic. So what the new observability framework does is gives you a way to monitor the behavior of systems, in real time of a deployed system, so you can proactively identify how the system is behaving, and in particular, note potential changes in behavior, or degradation, for example, in system behavior, so you can take action to mitigate whatever that behavior might be, or, prevent a larger failure of the system.
Okay, so how does this framework work? Is it integrated with DDS? Is it built on top of it? And from a programming perspective, is this going to be something that's independent of the actual applications that's going to be using DDS?
The system is built on our Connext framework, so it takes advantage of the fact that Connext is the way all these different subsystems communicate with each other. And you can look at sort of Connext as the glue between the applications and the underlying network. So Connext has visibility both, into how the application is using Connext, but also, into how the underlying network is using, since we're sort of the layer, you could say, some people say the middleware layer between the application, and the underlying network. Mm-hmm. So the observability framework is integrated with Connext itself, so you don't have to make any changes to the application to take advantage of the observability framework, if that was the question you were asking. So the observability framework is kind of an add-on to the framework that gives you the capability to monitor how the system is behaving. So it has, yes, I think as we're showing here on the slide, it has a library that becomes effectively part of every application that's using the framework. So the framework itself, the Connext framework, includes a library that gets linked into all of your applications. So within each, application now, there's a library that's monitoring the key statistics about if performance, for example, over the network, and, are there messages getting lost or messages that have to be resent, for example. So every application has this observability library that's collecting data about its behavior and then forwarding that data to a collector service that you see here. So the collector service is now aggregating data coming from different applications running on the network, each application having its own instance of the observability library. And then if we build this out, the next step. So the collector service is collecting all the data, coming from different applications within the system. And it's doing a couple of things. One is it's storing that data in a database, so using Grafana Loki to store log information, and using Prometheus, which is a common time series database, for example. This is in our reference implementation, to store all the metrics. So the metrics being things like, how many messages are being sent and how many messages are being resent, for example. So the collector service essentially stores that information. And then also, if you move to the next, provides a way then to view that data in a dashboard that can show you, give you a real-time view with some historic data as well, since it's using the databases, of how the system is behaving. So you can both, identify changes in behavior. You can kind of see there's some color coding in the dashboards here. So things that, look healthy, maybe I'm not, no messages are being lost, so I'm going to paint it green. And then if, messages are being lost, maybe I'm yellow or red, for example, so that you can see that something, isn't completely healthy in the system. And this is all monitoring the system, in real time. So you can see also changes in trend over time. Great. So here we're seeing that the dashboard now can actually, update in real time. So I'm actually monitoring here the real-time behavior of the system, and can, so see that if, for example, that there was an error, I can go drill down from the dashboard to see what the specific error was. You can see, I can see traces over time to detect changes, and you can also set up alerts, for example, if certain, conditions or thresholds are met. And because we're using standard, databases, and in this case, standard Grafana dashboards, these are fully customized by the end user of our framework, that's actually developing the applications. So, these can all be customized, based on the needs of the specific application, and as well, developers can add application-specific visibility into this as well. So you asked before, if this is, customizable by the end user, kind of extensible to cover the application, and the answer is yes. I mean, we're providing, something that works out of the box, but is completely customizable by the end user, so that they can use what we're providing, as a reference and as a starting point, but then they can add their own capabilities to it based on their specific application. So it's not just limited to monitoring and observing the middleware. It can be extended to the application itself, so that you can get a consolidated view, for, our customers. If they're, providing a service, they can use it to monitor the service, or if there's, providing something to a customer, the customer can use it to kind of monitor the overall system health, which includes the middleware and the applications itself.
Now, does the API utilize, or actually the library utilize the underlying DDS framework, or does it use a sideband channel, or is that something also that is customizable?
So it uses Connext itself under the hood, since we provide that, real-time data distribution, and it can also integrate with a common framework for this telemetry data called Open Telemetry as well. So Open Telemetry is a standard framework for this type of data, which lets you then take advantage of other third-party capabilities that are integrated with Open Telemetry. So it expands the ecosystem.
So we were talking before about some of the benefits of this kind of approach. What are those, and can they be incorporated into the application via the APIs you were talking about?
Yes, so these can be incorporated into the application, kind of as I referenced, not just through the APIs, because DDS itself provides, the API for distributing data, the standard that we support DDS, but because we're using, standard frameworks as part of this, that also have their own APIs as well. Developers can use those APIs. For example, Grafana, if they're building their own dashboard, would use its own API. So the benefit is that I can have, a consolidated view of the whole system, not just limited to Connext itself. So I can monitor Connext as well as non-Connext technologies, and we've, tried to integrate, with those observability components that are already widely used out in the industry. So if, customers already have some observability with their systems or applications, it's likely that they're using the same technologies that we're using. And in fact, this was driven by input from our customers in terms of, the capabilities and infrastructure that they'd like to see. So that's, one benefit is it's, a holistic view to our customers of their whole system. And again, as it relates specifically to the network itself, it lets them, quickly troubleshoot issues, through dashboards and alerts to identify problems or, potential problems, because there's some change in behavior where you can see performance degradation, but it's maybe not so bad that the system is failing. But if you see degraded performance, there might be a problem somewhere in your system, maybe, a poor network, or maybe there's a CPU that's overutilized, for example. You can detect those problems earlier. So, the whole goal is, given that these are typically mission critical applications that we're deployed in, is, identify likely problems before they occur, so I can, take action proactively. to ensure, both that the system is behaving with its best performance, but also that there aren't any failures. And the architecture of the system, I mentioned with the collector, is really designed to be highly scalable. So, from something that might be running, at one physical location to something that could be, globally distributed as well.
Great. Well, thank you for filling us in on the new observability framework for DDS.